Hello, my name is Meryem Yıldız. In this video, I would like to briefly explain the project I have done in the scope of İzmir Kadir Çelebi University Microprocessors course. In this project, animations are done in graphical LCD using PIC18F45K22 microcontroller. I tried to be portrayed a television. Here, graphical LCD represents the television screen and keypad represents the remote control. The scenarios of the project are, firstly, this project circuit has graphical LCD and PIC18 and a keypad. In this keypad, different animations are displayed according to the key to be pressed. Secondly, graphical LCD shows an animation when a key of keypad is pressed. When another key is pressed, GLCD shows you another animation. And lastly, this project will include pause, forward and backward buttons. These buttons are used as external hardware interrupts while GLCD showing an animation. Here is the Proteus schematic of the project. I used the Proteus 8 version for doing the circuit simulation. Equipments that I have used in the project. In this project, I use 8 different components, and these components are entire 128/64 graphical LCD, GLCD, buttons, capacitors, crystal, keypad phone, 10K resistor, PIC18F45K22 microcontroller and potentiometer. In my project, I use 4 push buttons. These buttons used for take input 1 of 3 of buttons. These 3 buttons were used to apply interrupts. Each button is used to pause, forward and backward animation. One of the buttons is used for master clear part. I used the potentiometer for adjusting the graphical LCD contrast. Now the system is not working. Pressing the start button, now the system is working. When the Proteus simulation is started, the welcome letter is first reflected on the screen. GLCD doesn't display the screen animations without pressing the specified keys on the keypad. On the welcome screen, animations that we can select via the keypad are shown. When we click on the keys of keypad to follow the specified animations, the animation associated with the clicked key starts to show. The animations starts moving forward. When pressing the button 1, the car simulation is starting with forward direction. I can pause and also backward the simulation. When I press the button 2, the fish simulation starts to moving forward. I can also pause and backward the simulation. And lastly, when I press the button 3, the main speaker animation is starting with forward direction. I made the animation of the news announcer different from the other animations. When K3 is pressed on the keypad, the female announcer is drawn, and besides, there is a balloon of empty speech. The words appear one by one. Let me explain creating bitmap and code of bitmap images. First of all, I choose pictures for the animation. I choose a car, a fish, and a new speaker photo. The new speaker photo was colorful. I made it monochromatic. I load these bitmap images to graphical LCD bitmap editor on the Tools tab of the Microprocessors program. The bitmap image codes are shown at the bottom of the tool. The generated code is nothing more than a constant character array that contains information that the GLCD should be illuminated to display the image. For a graphical LCD of 128 64 pixels, size of the array would be 1024 bytes. Then I saved these codes separately as a C project. And I included them in the project later. I did these steps with using the project at existing file tab. Now I will try to explain the descriptions of codes as much details as possible. This is how the code works. Everything starts from void main function. Firstly, I configure ports as digital input output pins. Flag variable is set to 1. It means that the animations start with forward direction. Break flag variable is 0. There is no interrupt. I use the external hardware interrupts. As I said before, there is the algorithm for interrupts. Firstly, I decide the interrupts are on the rising edge. Intet G0, intet G1 and intet G2 bit is set to 1 on rising edge. Then I clear the interrupt flags. Interrupt flag bit is 0, and secondly interrupt 1 interrupt flag bit 0, and interrupt 2 interrupt flag bit 0. And enable the interrupts. And this part is important. Global interrupt enable bit is set to 1 to enable global interrupts. Here the keypad and GLCD module connections. I found the connections in Microprocessors website, GLCD library and keypad. Bit break flag variable. I use this variable so that I can exit immediately from the animation when there is an interrupt to break out from the loop. Without this variable, when there is an interrupt, because the functions animation forward and animation backward contain a loop, loop will continue and move the image across the screen until it's less and equal to 120. To avoid this, the only way to get out of the loop is use to break statements. So in each loop step, I am also checking if variable break flag is set to 1. If yes, we break out from the loop. And the only time this variable will be 1 is when there is an interrupt. Void interrupt function. If interrupt 0 bit is set to 1, flag is set to 1, break flag is toggled. This is the complement. If the variable was 0, it will be 1, and if it was 1, it will be 0. Void poll kpad function. Here I am checking for the value of image pattern to know the image. Check when I call animation forward function in the program on line 128. Inside animation forward function, I am checking if image pattern is equal to 1. GLCD shows car animation. If image pattern variable is equal to 2, the GLCD shows fish, and if image pattern is equal to 3, GLCD shows me speaker animation. GLCD partial image X, Y, picture height, picture width, picture height, and image. In my project, we are only changing X, increasing it by 5 to shift image to the left. This will be the new X position where the image will start. The rest are left unchanged. Y is equal to 0. To leave the complete height of the image, 128 is the desired width of the image. 64 desired height of the image, 128 width of original image, and 64 height of original image. Void interrupt. I am checking which button was pressed. For forward, flag is set to 1. For backward, flag is equal to 2. And for pause, flag is equal to 3. Then in while one loop, this loop will continuously. I check the value if flag to know where to jump. I used X for forward and Y for backward just to make the code easy to understand here. In animation forward function, I use X variable. In animation backward function, I use Y variable. But I can still use the same variable X for both because their values are the same. Y is equal to X. X is equal to Y. Interrupt 0F bit, interrupt 1F bit, and interrupt 2F bit will change automatically to 1 when there is an interrupt. That's how interrupt works. And the interrupts will be caused when I press the buttons here. This is the end of the video. Thank you so much for watching.